Alright, so this video is going to kind of show you a few features of the TI-84 calculator. So let's say we have this as our equation, which is a parabola. It opens down because it's negative. So we can type that in, and I'll show you a couple of features on the calculator that can kind of figure out, you know, x-intercepts, y-intercepts, things like that. So first thing I did, or you can do, is type in the equation and then hit graph, and I did zoom 6 because that's typically where you would be at as far as the dimensions of your screen. So if you hit zoom standard, that's usually the general snapshot of where you might want to start. Alright, so if you were asked to find, well, let's take a better look at what we have. It doesn't even look like a parabola here because it's just this portion of the graph, so it's clear that we're going to have to zoom out. So zoom out, and nothing happens until you tell the calculator where to zoom out from. So I'll just go right here. I guess it doesn't really matter. Go right there, and then I can hit enter, and it actually does the function of zooming out. And that was actually that was enough. You may have to zoom out again, so you could hit enter again. And if you had gone too far, which I have now, you can always zoom in. So zoom in, and you can put that in wherever you want and hit enter. I really like the zoom box. So if you go to zoom box, you can put the cursor anywhere on a corner. So if I wanted a snapshot of the parabola, kind of like cropping a photo, I'm going to put it in the upper left corner, hit enter, and then I can drag my cursor to create a picture of my parabola. So there, if I hit enter, there's my zoom box. Okay, so if you're asked to figure out the x-intercept or x-intercepts, we can do that on the calculator and get the exact answer. A lot of our features are right here under calculate. It's in blue here, so I'm going to have to hit the second button first. So second, calculate. Now the zero, finding zeros of a function is like finding the x-intercepts. So I'm going to calculate 0. It asks us for the left bound, so I'm going to start by finding that x-intercept right there. We need to make sure that our cursor is on the left side of that x-intercept. So anywhere over here is fine. I'm going to hit enter. Once I get it on the left side, it says right bound, so I'm going to go to the right. As long as it's on the right side of that x-intercept, hit enter, and now it says guess. We're going to go back to the left and put it on where we think the x-intercept, our answer, is. Guess, I'll put it right there, hit enter, and it'll tell us our exact answer, 40.736. So that's your x-intercept, 40.736. Okay, if you wanted to find that x-intercept, you could do the process again. So second, calculate the 0. Now we have to go all the way to the other side, the left side of that x-intercept. There's my left bound. Go to the right side of it, right bound, and then I'll put my cursor right where I think the x-intercept is, and there's my other x-intercept, negative 0.736 comma 0. So those are your x-intercepts. If I wanted to find the y-intercept, I'm going to zoom in a little bit. Actually, I'll do that next, but I'll zoom in. Okay, so zoom in, hit enter. I'm zooming in right there. So you can see that that's my y-intercept. Under the calculate button, second calculate, I can choose any value I want. So if I want to know the y value when x is 2, it'll give it to us, 10.6. If I wanted to know the value anywhere, as long as it's in the domain, you could do that. If we're looking for the y-intercept, all you have to do is plug in 0 for x, and it'll give us our y-intercept at 3. So our y-intercept, all you have to do is calculate when x is 0 and so I'm going to zoom out again, and I'll show you how to find the vertex of our parabola. So the vertex is that highest point. Sometimes it's the lowest point if it's opening up. So on our calculator, it has a feature that can tell you what that vertex is, and that's under calculate, and it's under maximum. So we're going to calculate the maximum there. So maximum means like it's the high point, the peak of, local to where we're at. What's the highest point? Well, we're trying to find that right there. Again, it's asking left bound. So I'll put my cursor to the left side of it. Anywhere over here is fine. Hit enter. Now we're going to go on the right side. Hit enter, and I'll guess. So what is the vertex like right there? And it tells us that it's 20 point, a whole bunch of zeros, 1. So that's actually 20. It's rounding it off a little bit, but the actual answer is probably 20, 43. So we can conclude that it's probably not 20.000001. It's 20, 43. So that's your vertex. If I asked you what's the maximum of the parabola, it would be 43, because the maximum or the minimum is always just the y value of the vertex. If that was the path taken by a projectile, like we threw a ball through the through the air, how high did it go? You would say it went 43 feet in the air if it was feet. Okay, so it's the y value of the vertexes, either the min or the max. Alright, another feature on this, unrelated to this, is if we were trying to model data using a linear equation. So if you have a scatter plot, and let's say my scatter plot looks like this, and we plot them all, and I wanted to represent that data set with a linear equation, you can see that as we go to the right, it does increase. To find the line of best fit, we would be finding the line that goes right through the middle of the data, and that's called a linear regression. Linear regression is a line of best fit. If the data, for example, looked like this, that would be an example not of linear. It looks like it would be quadratic, which is modeled with a parabola. You can see that it would probably look like this. So a quadratic is an equation producing a parabola. So you wouldn't do a linear regression here probably, you would do a quadratic regression. Your calculator can do lots of different types of families of functions with the regression capabilities. So let's say we've got just a nice simple XY table, and we can talk about what they represent, but it really doesn't matter at this point. I'm just going to show you how to do it on the calculator. So if we're trying to find the line of best fit just with these 4 dots, 2, 20, 5, 22, and so on, we would go to stat, and you could edit and put the x's in one list and the y's in the other list. Now I have lists already in there, so I'm going to arrow up, go to L1 up there. Don't hit delete, that'll wipe out the whole column. I'm just going to hit clear, enter. So clear enter makes them all disappear, but it keeps the L1 column there. So clear enter. If you wanted to, you could certainly just go through and delete the individual cells. Okay, so 2, 5, 12, 18 is my L1, which is my X column, 20, 22, 26, and 35. Okay, so I have them entered into L1 and L2. Now the calculator will tell us what the best line is to represent that data. So I'm going to quit, quit, go back into stat, so hit stat, calculate, linear regression is this first one. It's actually number 8 also. It's just in a different format, but I don't see a reason why you'd ever do number 8. Number 4 is kind of the mx plus b form. So number 4, we're going to do a linear regression. Hit enter, and if you just want the answer, you could just go enter, 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 and we get our answer. So the equation, the line of best fit, would be y equals 0.8998 x plus 17.426. So that gives us the line of best fit. If the question asked you, is this linear or not linear, the relationship with those, you could enter them into your list, both lists, which I did here, and we could plot them on the calculator. You could graph them on graph paper and see if it forms a straight line, but the calculator will do it also. So put them in your lists, and then you can go to stat plot right up here. Second stat plot. All my plots are off, so I'm going to hit enter and turn my plot 1 on. Notice L1 and L2 are the lists that it's going to plot, which is what we want because that's where we entered it. You can choose any graphic you want. That's probably the best one. So hit enter. So our plot is on. Now I'm going to graph. Okay, so sometimes our points are way off the screen. And I still have my parabola going through here, so I'm going to get rid of my parabola. Don't need that anymore. A neat feature is you could go to zoom and then go down to number 9, and that takes a snapshot of whatever data you have plotted. So now there's my 4 points. So it looks pretty linear. You could also make the argument that it's quadratic. Looks like it's kind of curving. So that one's not as obvious. I just made up the numbers. But if I wanted to show the line of best fit, which you may or may not have to do, you probably wouldn't, but it's kind of a cool feature. Stat, calculate linear regression back here. We could actually store the equation. So I'm going to store it in as y1, like our first y on the y equals. So to do that, you go to vars. Right there. So variables, the y variables, function, y1. So we're going to store, the calculator is going to figure out the equation and it's going to store it in y1. So that was an answer we already had. If you go to y equals here, we now have that stored in to y1, and if I graph it, it will actually graph the line of best fit. You can see that it's a pretty good representation of the data, a line going right through the middle of it. If you wanted to do different types of regression, a quadratic regression, calculate, it's just the same process. You could do a quadratic regression right here. You could store that into y1, and you can see that it's a pretty good representation as a quadratic also. It goes through the points. All right, I think that's all I'm going to talk about right now.